Small stars. Small stars have a mass of up to about 1.5 times that of the Sun. They begin to form when a region of higher density in a nebula condenses into a huge globule of gas and dust that contracts under its own gravity. Within a globule, regions of condensing matter heat up and begin to glow, forming protostars. If a protostar contains enough matter, the central temperature reaches about 8 million degrees Celsius. At this temperature, nuclear reactions in which hydrogen fuses to form helium can start. This process releases energy which prevents the star from contracting further and also causes it to shine. It is now a main sequence star. A star of about 1 solar mass remains on the main sequence for about 10 billion years until much of the hydrogen in the star's core has been converted into helium. The helium core then contracts and nuclear reactions continue in a shell around the core. The core becomes hot enough for helium to fuse to form carbon, while the outer layers of the star expand and cool. The expanding star is known as a red giant. When the helium in the core runs out, the outer layers of the star may be blown away as an expanding gas shell called planetary nebula. The remaining core, about 80% of the original star, is now in its final stages. It becomes a white dwarf star that gradually cools and dims. When it finally stops shining altogether, the dead star will become a black dwarf. Structure of a main sequence star. Core containing hydrogen fusing to form helium, radiative zone, convective zone, surface temperature about 5500 degrees Celsius, core temperature about 15 million degrees Celsius. Structure of a nebula. Young main sequence star, dense region of dust and gas, mainly hydrogen, condensing under gravity to form globules. Hot ionized hydrogen gas emitting red light due to being stimulated by radiation from hot young stars. Dark globule of dust and gas, mainly hydrogen, contracting to form protostars. Structure of a red giant. Surface temperature about 3500 degrees Celsius. Cooling, expanding outer layers glow red. Outer envelope consisting mainly of hydrogen. Shell where hydrogen is fusing to form helium. Intermediate layer consisting mainly of helium. Shell where helium is fusing to form a carbon. Carbon core temperature about 100 million degrees Celsius. Life of a small star of about 1 solar mass. Nebula. Cool cloud of gas, mainly hydrogen and dust, dense globule condensing to form protostars. Protostar, duration 50 million years. Glowing ball of gas, mainly hydrogen. Nuttall cocoon, shell of dust blown away by radiation from protostar. Main sequence star, duration 10 billion years. Star producing energy by nuclear fusion in core. Red giant, duration 100 million years, at least 70 million kilometer. Cooling, expanding outer layers. Planetary nebula, duration 35,000 years. Dense contracting core, outer layers form expanding gas shell. White dwarf, about 13,000 kilometer, very dense core, 1 teaspoonful weighs about 5 tons. Cooling white dwarf, cooling core glows red. Black dwarf, called dead core.